This video was recorded on March the 13th, 2023. The topic of today's video is using the tools that are available to help the programmer with the Camel99 Forth system. The way we get those tools is we include the file called disk1.tools. Now you'll notice it's also loading something called forget, something called case, and defer. Case and defer are just programming language extensions that the tools code uses to make it work. Forget is actually a word that we can use in the language now that tools has been loaded. Let's get a new page, the word page, and let's define a word called test, which does this, and we can try it, and it works, and we decided that's not really what we wanted to do. We can now forget test, and when we type test now, it's not recognized. So that's forget. Now, the thing to remember about forget is it forgets everything that was defined before the word we forget. We could actually forget something very important in the Forth system here, and everything from that point and above would disappear and the thing would become unusable. That's Forth. There is no safety net. So let's just test that out. Let's go like this. We'll make a word called QWERTY. What does QWERTY say? It says, keys are my life. And we'll make another word test, and it will just go 99. It'll just put 99 on the stack. So we can test that. Yep, there's the 99. We can test QWERTY, and it does that. Now, we defined QWERTY first, and then we define test. If we forget QWERTY and we try to run test, it's also gone. So that's what I wanted you to understand. Forget is not forgetting a specific word all by itself. It forgets itself and anything that was defined after itself. Remember, the Forth Dictionary is searched from the newest definition backwards, and that's why forget does it this way. Okay, so there's forget. What other tools have we got at our disposal here? Well, we have a way to look at the contents of the data stack without erasing the contents of the data stack. It's called .s. So as you know, we can look at what's on the data stack with the word dot, which just prints the contents of the data stack. If we do it one more time, it's empty. The 0 is just garbage that's in the dictionary at that place, on the stack memory at that place. So it could be anything. Let's try it again. Yeah, see, we get 159. Okay, now what if we wanted to see what's on the stack and not destroy it? Well, let's do this. And if we do .s, we can see what's on the stack. Very handy. Why would you need that? Well, let's say you're building some words and they do things to information that's living on the data stack. Let's say we make a word, we'll call it flip. And what it does is the over operation and the over operation. Okay, so now we look at what's on the stack there, 1, 2, 3, and let's see what happens when we run flip. Flip does a second 2, 3. So it took 2, put it over top of the 3, then it took the 3 and put it over top of that new 2, and that's what we got. Now, if I was going to name flip, I would probably change it to something called to-dupe. In fact, that's the standard Forth word for this thing of duplicating the top 2 elements on the stack. So let's forget flip, because we know about that now, and let's define our new operation as to-dupe over. Oh, to-dupe isn't unique. Now what that means is to-dupe is already in the dictionary somewhere, and in fact, as I said, it's a standard Forth word, so it's part of the Camel99 Forth kernel. But we've redefined it. So what will happen? Well, the newest one that's defined is the one that will get used from now on when we use the word to-dupe. All the other places that to-dupe was used in the Forth system are still using the old one. Nothing changes there. They're compiled. But if we compile anything new now, it will use this new definition of to-dupe, which will work the very same. So let's take a look. We've got that. Let's pop 2 of those off. There's our 1, 2, 3. Let's do to-dupe. And sure enough, the top 2 items of the stack are duplicated. Now, this is handy if we were to make a word called eat2. Let's say some piece of the program you need is going to consume 2 elements on the data stack. You can now run flip. Let's do it. Let's run flip. Oops, did I forget flip? Oh, I did forget flip. Let's add flip again. Over. Even though we know it does to-dupe. So we go 1, 2, 3, and we type flip, and we see we've got 2 there, and then we're going to run this other routine that eats 2 and takes them away. And so by using .s and interactively testing your little program pieces, you can very, very securely know that you've put the right number of things on the data stack. The program that's going to pick them up picks up the right number and leaves the correct number behind if it has anything that it returns to the program. So that's the function of .s. Let's take a look at how we look at the inside of memory here. What's in memory? So Forth has a word called variable. Let's make a variable called x, because that's what they're always called in programming demonstrations. Let's take a look at our stack. We still have our 1, 2, 3 there. To get rid of what's on the stack, just type anything that's not recognized and the stack is cleared. Now, if we type x on the stack, x as a variable there, and we look at the stack, it has a negative number. What the heck is that? I'm going to switch to hexadecimal notation and show you a feature of the tools. Now when I look at the stack, it gives us something CBB8, which is the hexadecimal address in the computer's memory. The variable x, unlike many languages, gives you the address in memory of where the data will be stored. The tools utility gives us a thing called question mark. I'm going to just pop that off. So that if we get an address from x and we put a question mark after it, and we need a space between each Forth token, we can see that 0 comes back to us. 0 is what's inside the address where variable x is, that variable x has for its use. So x is a variable, but it tells us where it's keeping its information. And the question mark reads that information and prints it. Let's put a number inside x. We do that with a number, the address of the number, and the store operator. I've read that Charles Moore, who invented Forth, used that particular character because he didn't want to type the word store. So he used a piece of punctuation. It's brief. Once you learn it, it's yours. So let's look at our stack. Nothing there. Even though we typed 99 and we put x on the stack, which was the address, store picked both those up and put 99 inside x. Don't believe it? X space question mark 99. So that's the question mark tool that comes with the tools file. Another way to look at memory is to use something called dump. People who are familiar with older debuggers that existed back in the old days of computing would know that dump just lets you see the contents of memory. So let's take a look. I'm going to look at address 0. And I'm going to look at, let's do hex 100 bytes and type dump. Now notice, again, Forth uses parameters by putting them on the data stack, then something picks those up and uses them. Looks backwards, but that's how Forth operates. So there's 100 hex bytes, which is 256 bytes, of the contents of the read-only memory chip, the ROM chip, in this computer. And we can see that on the left side, there's a column that shows us the address. Then there are 4 memory cells, or 8 bytes, of hexadecimal numbers. And if any of the bytes that are in that memory are printable as ASCII characters, on the right side column, those are printed out. If they can't be printed, if they're invalid ASCII characters, they just print a dot. Now, that's not telling us very much. We don't know what all those hexadecimal numbers mean because we didn't write the program that is living in the ROM chip. I did write the program that's living at hexadecimal A1000, which is the Forth system we're using right now. And if we dump that memory, I can pause it by pressing the space key. We can see there are words there. And those words, where you see a word you can actually say, exit, do call, do var, do con, do user, do does, execute, perform, question mark, branch, and branch. Those are all words in the Forth system that we're running right at the moment. And that is the so-called dictionary of the Forth system, where all the words live. So that's dump. And there is another pile of memory that's associated with this little computer that's connected directly to the video chip. And there's another word here called vdump that we can use. So let's take a look at, I happen to know that 1000, hex 1000, is free memory. And yeah, there's nothing there. We could put something there. Let's go hex 1000, 100 hex bytes. Let's put the character $, and we do video fill, vfill, and let's look at it. 1000, 100, vdump, not regular dump. Vdump, remember, dumps video memory. Dump dumps the RAM, random access memory connected to the CPU. There's what we just did. We filled up a chunk of that video memory with $ characters. So this is how, if you're doing memory accessing, putting things in memory, and you want to double check, did my program do it correctly? You jump into the interpreter here at the console and just examine the memory and see if it looks right. The final thing that we have is something called .free. And .free lets us see that we are actually working with enough memory to do the job. So we can see in the low part of memory, we have 8K. In upper memory, we have 14K. And in the video display peripheral, VDP memory, there's 10K available to us. So that's tools on the TI-99 with Camel99 Forth.